Hello everyone, welcome back. So in this video, we are going to understand a very important question from the LeetCode is power of 4. Okay, this question is quite easy, right? So you can think that it is not beneficial for your interview. That's true because this type of questions you never gonna ask in the interview because this is very easy. Okay, but still there's a couple of ways we can discuss about this approach where you will understand and you will learn the concept. So I'll suggest please keep watching and I'll try to cover almost the methods that I know, right? I'll try to cover that. Okay, so first of all, understand what we have given in the question. We have given n, as you can see, as an input. N is an integer number, n, and it is saying we have to return true if it's power of 4. Okay, so if it is a power of 4, right, 4 to the power what, 2 is equal to 16, right? It's power of 4, otherwise return false, right? So n equal to, if we have 4 to the power x, right? If n is equal mathematically, it means we have to return true, right? This type of questions we have seen in mathematics in our childhood, right? That you have seen. Okay, now question saying that constant what we have given is n can be large, okay, between the integer uh, bonds, you can say. Okay, so how we are going to solve this type of problem? Okay, very easy, you can do mathematically, that is obvious, right? But apart from that, there is a bitwise trick and will be used in something mathematically, you can say, right? In this code where we are going to check how to check if the number is power of 2. So that we will see, and we'll see if the number should be greater than 0 and should be some value should be there that will apply the bitwise operator, and this value, if it gives x is giving equal to 0 with the bitwise operator, it means what, it's a power of 4. Remember? So let's understand how. If you remember, I have also discussed about the power of 2 in the previous videos where we have done that, right? Let's try to understand in this video how to implement it. Okay, so if you remember the question power of 2 we have seen, right, where we try to see we were checking how to check if the power is power of 2, right? Remember, 2 to power x we need to find, and this is the number we was given, right? So in that case, if you remember, we used to check if x is greater than 0, and then we are checking with the bitwise operator x minus 1, right? If it equal to 0, it means what, this is your uh, power of 2, right? So like that we will go and we'll understand. Okay, so this is very easy. If we want to implement similarly, let's suppose if we have given this and we have given, right, and just what we will do, let's suppose I'll write condition if n equal to 0, right? If our condition says n equal to 0, means we return what, false, means the else condition we have to return if n is 0, right? Will return false, return false. It's not power, because if anything you will put as a power, let's suppose 0, it will give you 1. So this edge case we will write. Understand? You know that if we will pass any power, it will give you 1, 5 power, right? At least if it is equal to 0, right, we will return false. Okay, that we will do. Then we should check in the while condition is that if I will find the mod with the 4, that is very simple statement that we are going to write, right, like this. If it is, right, means if it is remainder is coming 0, it should be divisible. It means it is divisible. Remainder is coming 0, just divide by 4. You will divide by 4, right? You will get something. So you can write this like this also. And if you want to divide it, just provide the operator. Give me 1 second, guys. Operator like this, and you will write 4. So each time the while loop will go, right, it will keep dividing. Let's suppose we have 64 we have, for example, right? We know that it will be divisible by 16 4, right? Let's suppose how, if we'll put 4 here, if I want to divide it, first time it is coming, it will 1, then what is coming? 2 and 4, right? Then 6 time we will divide, it will be done, right? So if I will say it can be divisible very first when n equal to 64. Give me one second, give me one second. Let's suppose n equal to 64, it is divisible, we get 0. Then we'll do what? N by 4. N by 4 is equal to what? Means 64 by 4. We know that what we will get? 16 we will get, right? Means this is your n. We'll keep dividing this again. 16 is divisible again by 4. We'll get yes. We'll get okay. Divide now again. We'll get 4. Like that, we'll keep going here, right? Until we again we know that it is coming 4. Divide by 4 by 4. What we will get? We will get 1, right? So here, once this is done, we just need to make a condition. What is the condition? If it is divisible, we are done. So 1 is divisible by 4. No, it means the value will not contain, not continue. Just you need to do, you will do return what? N. But return n only if it will equal to 1. If it is equal to 1, return true or false. If it is not equal to 1, it will return false. If it is equal to 1, it is return true. Understanding? So it is very easy. Let me show you how. Okay. So very first, what you should write? You should write condition edge case. Edge case is what? N equal to 0. Because any power of 4 to the power 0 or anything will happen in any number having the power 0, it will return 1, right? So return false. If it is coming, means it is 1, because it is 1, and equal to not 0, it is equal to 1, right? Means to 4 to the power 0. I'm saying if we are writing 4 to the power, how we can write? Okay, let's suppose I write 4 to the power 0 like this. Means we are getting what? 1. Means if, and we are saying if, and we are saying if n equal to 1, right? In this, what we will get? We'll return false. No, not false. Not, this is not n, this is 0. Don't think much. It will give you 0, means return false, simply. Okay. Then you make a condition, while condition, and you check if n is divisible by 4. Is it divisible? Means we'll give what? Remainder should be 0. If remainder is coming 0, it means what? We need to divide. So we have checked 64 is divisible by 4, means we are getting 0. Remainder is coming 0, means 64. Let's suppose this is 60, n is 64. Divide by what? This 4. How many n? Now n is 16. Again it will go and check n divisible 16 is divisible by 4. Yes. Divide 16 by 4, means we'll get 4. N equal to 4. Is 4 is divisible by 4? Yes. Again divide by 4. How many will get? You will get 1. Once you will get 1, we'll check again. Is 1 is divisible by 4? No, we're not getting independent 0. Means the loop of while loop is done. It means we'll come here. Here n is equal to 1. So we'll say if n equal to 1, return true. Otherwise return false. Right? This is a very simple approach that you can do mathematically, right? This will work, I know. So we know that these cases will work, right? As you can see, all these cases will work. Now think about, okay, so if you talk about the complexity, what you will get the complexity? Obviously, the space complexity and time complexity will become O of 1, because we are directly calculating and we are dividing, right? Now think about, so this suppose will take both O of 1, right? Now think about, can we do this any other approach? Yeah, we can. If we'll pre-compute all these values, let's suppose you can say 4, 16, something like that, means related to the 4, right? All the multiplication of 4, it will put in some list, right? And then you will directly check if in the list contain if the list contain n, return true. Okay, that you can do. That is very easy. Try by yourself and write the code in the comment section. I'll give you thumbs up if you'll do that. Okay, understand now how we are going to implement through the bitwise operator. Okay, so let me remove this. You try this your code. Okay, now think, if we want, give me 1 second. So now think, if we are going to use the bit manipulation approach, right, where very first, if this n we have given, so very first what we should do, we should check this n, is it a power of 2? Simple thing. If any number is there, let's suppose 2, what it will give you? It will give you 16, right? Can we say that if power of 4 to the power 2 means giving 16, right? Can I say how many times I will write the power that I will get 16? That 2 to the power 4 means we will get 16. So before checking this 16, can I check this power of 2, right? So if the n is power of 2, understand, if this number is a power of 2, right, this will be the power of 4 also. So we know that how to check this one. How? If let's suppose x is greater than 0, right, and if we'll apply x and x minus 1, right, if equal to 0, if this condition works for us, if x and x minus 1 is equal to 0, right, it means this is the power of this, right? So now the problem is between power of 2, right, and when the when x is power of 4. Understand? Means if 2 to the power x is there and 4 to the power x is there, right? That's all. Correct? Means when x is a power of 4, right, odd power of 2, when x is not a power of 4. Understand? Let me tell you how. So very first understand this part, okay, how this works. Okay, so can I say the power of 2 means the only one bit is binary representation, right, means 1, or other are 0. Remember, means we have 8 4 2 1. Remember, so if I'll write 1 2 3 4 or 8 or 3, remove 3 is not required, right, 1 2 4 8, this is required for our example. Okay, so can I say if this is 1, we can represent as what? 0 0 0 and 1. Only one bit is there, right? If you want to represent only one bit, right, these are the one bit, right, one bit thing means 1 2 4 and 8, right? So if this is only one bit is there, so all other 0. If you talk about 4 means 0 0 1 0. If you talk about 4, 0 1 0 0. If I talk about 8 1 0 0, means there is only one bit is there, right? That is 1 in all of this in the binary representation, and rest of the what, it is 0, right? Means if you notice here, only one bit set is there. Can we say that? What is there? Only one bit set is there. 1 1 1 1, like that. So what happens if I will apply, if we will say this is your n, right? If you say n minus 1, right, so if you take a power of 2, right, to the power of what, 2, x, or you can say n, for example n, right, and subtract minus 1, right, so that one single bit becomes 0, right? So all the bit to the right of it becomes 1. For example, this one, if you take, what is we have, if you suppose n equal to 8, so if n equal to 8 means what we have in the binary representation, right, what we have in the binary representation, we have is 1000, right, 1000, not 1000, 1000, we can say. So if n equal to this, if I want n minus 1, so how you are going to represent it? This will become what? It was 8, it will become 7, and to become 7, what you need to do? Just this bit become what? it become the only one single bit, that one was there, it becomes 0, right? And all the other bits, right, to the right of this, what it will become? It become 1. Remember? So this is called, whenever you do, if we have n and if you're doing n minus 1, understand? Means now if we will apply these two, right, n and n minus 1, so if n is a power of 2, if n is a power of 2, can we say that? So if we will want to check this n and n minus 1, so it should give always a result 0, understand? Because if you will apply the single bit here, right, what it will give you? A single bit in n become what? 0, and all other become this one. So how it will become? All are in the 0, it will become what? This will, it is 1, it is 0. So can I say, if I will do this one, let's suppose I'll write here 1 0 0 0 for the 8. If I'll do 0 1 1 1, what will happen? This is your n, this is your n minus 1, right? Correct? If this is n, this is n minus 1, means if we will write this, what will happen? Think. Because let's try to understand another example, for an easy example. Let's suppose, very easy, if n I am taking just 0 1 0 0, what is this? This is your 4, this is your 4, right? Then if I'll take n minus 1, right, what will become? 0 0 1 1, this is also coming 3. Can we say that? So if we will apply here also, what we will get? 0 0 0 0. So either you are taking here, it will become 0 0 0, either you're taking here, it is 0 0 0. Means the single bit in n, either here you see or either here you see, right? There is single bit, one is here, one is here, right? It becomes 0 in n minus 1, and so everything else doesn't align to make one in AND operation. If you'll apply AND here, all becomes 0. So this is the things we have to understand. Now understand another thing. Okay, let's suppose, okay, let's suppose if not a power of 2, okay, means, and we have, and if I'll take 0 1 0 1, this is your 5, this is not the power of n. If you'll take n minus 1, what you will get? 0 1 0 0, this is what? This is your 4. So if you represent 4 and 5 in the binary, right, and if you want the AND operation, right, between these two, between n and n minus 1, so what will happen? Think. Because this is 0, it becomes 0, this is 0, it becomes 0, this is 1 1, it will give you 1, right? This is 0 1 0 0 0 0 0 1 1 1 and 0 0 0. What will, what we got? It is not equal to 0. Understand? So this is not a power of 2, but these are the power of 2 that we have seen. I hope you understand. So it is easy to write, to say, if it is power of okay, so can we say the power of 4 must be the power of 2, and for that we have seen, if n is greater than 0, if it is n is greater than 0, right, and I will apply if the n and it's n minus 1 both gives you the result, right, from here to here, if it is giving the result, equal to 0. If it gives you 0, right, means this is a what? Power of 4. If it is power of 2, right, if anyone you want the power of 4, it must be power of 2. Means if 4 to the power 2 is equal to 16, means 2 to the power 4 is 16. Understand? Means the power of 4 must be power of 2. So power of 4 has only one bit, right? Even 0 to 4 you are taking, anything you are taking, right? And if you apply n into n minus 1, means AND operator bitwise, then what you will got? You will get 0, right? Then for any big value to check, like let's suppose you want to ensure that there is one bit in the even position, right? So if that is there, how we are going to check? So you have to return this one, right? So just you need to return it. But as you see, I have except I have not write here anything. Now what you need to understand, we know that the power of 4, the power of 4 means n, right, is a power of 2, but single one bit is always in the even position, right? If you count from right direction, right, remember, let me tell you how. Give me a second. So if you see here, right, all the single bit, right, when we saw that, right, we are getting what, let me write here again. Okay, so very first I'm talking about the power of 4, right? I'm saying there is a one single bit, right, always in the even position. Give me 1 second. Okay, how? Let's suppose there are some bit positions are there, right? Before that, let's suppose I'll say this is 1, we have power. If we write 0 0 0 1, means what is the bit position we have here? The bit position, right, at 0 we have, right? Now think about not 4, let's suppose talk about 4. What we have? 0 1 0 0. The bit position at 2. When it is at 0 0 position, means we can say bit position at 0, bit position at 2, right? These are what? These are even. If you take let's suppose 16, right, it will come out 8 4 2 1, then you will take 16, right, and rest of the thing will be 0. The three places are 0. Okay, so if we represent this, it will come out 0 0 0 1. This is for 1. Rest of the thing will become what? Is 0. So we'll take 0 0 0 0. So this and this. Okay, so at this position, this is the fourth position, right? Here we'll remove these things, right? What is the bit position is here now? Here it is 4. Similarly, if we'll take 64, think now it will become 1 here, right? Means no, 32 64, yeah, 1 is 0, then it will become at this position, right? Means rest of the thing is 0 0 0 0 0, right? Means this is at 6th position. Okay, means either you're taking 0 2 4 6. Okay, so power of 4, if we are taking 1 4 60 16 64, so power at a position at bit position at 0 2 4 and 6, right? So this pattern, if you see 0 2 4 6, right, this is the pattern. Only even position are get at 1, but even we can say only even positions get 1. Can we say that? And that is why we are getting the power of 4, this power of 4. So some things needs to done. So some concept you have to understand, that if you talk about the, see, if you talk about the power of 2, right, give me a second. Power of 2 vs power of 4. Okay, if you're taking power of 2 and power of 4. Okay, so you know the power of 2. Let's suppose talk about 2. The bit position is at where? Position is at 1. When we talk about 8, the bit position is what? Position is 3. 8, 4, 2, 1. See, what is the position of this? 1. What is the position of 8? 3. Correct? So we are seeing that, right? So these are the power of 2, but not the power of 4. These are not power of 4. These are not power of 4. And we say that these are power of who? Power of 2. These are power of 2, not the power of 4. And we say that. Similarly, if you understand the power of 4, right, there is only one bit set at even position that we have seen. What are those? Right, that we have seen at 1 was at position 0, right? Then we saw 4, right? 4 was, you can see here, right? 4 was at which position? Position at 2. Then we have 16, we have seen position at where? 4. Then we have seen 64, position at 6, I guess. Yes, like that we have to go and we have to see. Okay, so these are the difference. Only difference is if we are saying if it is power of 2, so power of 2, mathematically we can say if it is power of 2, it can be a power of 4 also, right? But in actual reality is that it is not the power of 2 is not power of 4. If it is power of 2, it is not power of 4. Can we say that? We can say that. So what we need to do, let's understand. If there is some positions are there, right, in binary, let's suppose I'll say 5. How we are going to represent it? 0 1 0 1, right? This is 4 and this is 1. So in binary, this 5 is like this, right? So if we have a very big number, right, let's suppose I'll take some values are there, or how many will take 16 bit. So for 30, let's suppose for 32 bit, right? Okay, if we have 32 bit, so we will need how many? 3 3 and 5 8. Okay, 8. So we need 8, right? If you represent in this one, it will become very big number, right? You have to convert it. Okay, like that you need to check like that. 1 1 1 1 0 1 0 1 0 1, like that you will go. In the last you will get 1. Okay, so if we are getting 32 bit of in binary, we will see, right? What we need to do, in the pattern, bits at even position are 1 and odd position at 0, right? So whenever we are getting at even position, right, we are getting at odd position we are getting 0, right? We have seen, right? Even will be 0 and odd will be, no, even will be 1 and odd will be 0, right? So for each bit, right, if we'll take the position index, for example, let's suppose if I'll take some index and we'll say, okay, for 32 bit, okay, go for 31, 30, 29, 28 and so on, right? 5 4 2 1 and 0, let's suppose. Then I'll say, okay, fine, we know that at 1 what we will get? 1. At 0 what will you get? 0. At 2 what you will get? 1. At 4 what you will get? 1. But we have 3, what you will get here? 3. I missed 3 here, you will get 0. At 5 what you will get? 0. So like that we will go, right? Then we'll say this is 20, what will get? 1. 29 what will get? 0. 30 what you will get? 1. 31 what will get? 0. Remember, so total from 1 to 30, if you write that, so all the even position are 1, right, and all the odd position are 0, right? So position index for, if you say position index for what, that we have seen 8 times 5, right, means we have to mask this one. check the count. Okay, right, in the binary, if you take, you have to mask it. Okay, so all the position that we are seeing here is what, at 0, at 0, 2, 4, 6, and so on, means all the event position is set to 1 bit. Okay, so how we are going to mask this, right? How you're going to mask it, right? Very first, if you apply n and this value, right, and if it is not giving what, not giving what, not like this, not giving what is 0. If it is not giving 0, means these bits are what, these bits are coming one single bit, and we know that if the single bit we are going to check, and if the single bit is in the n, right, and it is at the even position that we can see here, all the even position gives you what, 1. It means it's a power of 4. Can we say that? So very simple thing you have to apply is, let me clean it, is if we have n equal to 16, so if we'll represent this in the binary 0 0 0 1 0 0 0 0, like that we will define, right? If we need to mask it, right, let's suppose if we are going to mask it, we know that if we'll mask it 0 1 0 1, we'll do that. Then for 32 bit, right, we have go 0 1 0 1, will go 2 times. Similarly, we go 2 more times, 0 1 0 1, then 0 1 0 1, and maybe some more will go, right? Means we have to mask like this, we have to go, right, with the 32 bit if you have the masking. Okay, just you know this mask is there for the 32 bit will take how many bit, 32 bit will take here. Okay, just you need n and mask. If you do that, and if it gives you what, it gives you 0 0 0 1 or 0 0 0 for the 16, we are taking 16, right, for 16. If it is giving you the value this, means non zero. If it gives you non-zero, means this is your valid power of 4. I hope you understand, right? Means very little changes we have to do. Let me write it. So what you need to do, you just need to make these changes, and if it is, it should not be equal to what, 0, it should be 1. If you run this, right, this will work all the cases. If you run this, it will work. Okay, I've submitted, I guess. Okay, so you can see here, right? Anyways, thank you for watching this video. I'll see you in the next one.